Alrighty, what's up, folks? So I am unfortunately still out today, which is killing me to be stuck at home. But I want to make sure you guys still got some good content while I was out, so I made another video. Reminder of tie-dye stuff. Again, next Wednesday, we are less than a week away from tie-dye at this point. May 11th. Okay, 100% cotton white t-shirt. One full roll of paper towel. Do not forget. Don't forget. Don't forget. Okay? Don't forget. I'll find you. I know where you go to school. Alrighty. Anyways, so we're going to go ahead and take a look at our periodic table here. So at this point, you should have a lot of these things kind of filled out. So this is the back of your periodic table. So you should have Boyle's Law, Charles' Law, Combined Gas Law, Standard Temperature and Pressure, Kelvin, atmospheres. Like, you should have a lot of these already filled out because we've been going over them the last couple of days. So for example, standard temperature and pressure is 1 atmosphere, 273 degrees Kelvin, that kind of thing. Now what's going to happen today is we are going to hit up ideal gas law and the universal gas constant, which is part of the ideal gas law. So by the time you leave here today, you should be able to fill out pretty much this whole section of the back of your periodic table, which will be super helpful for you to use on quizzes and that kind of thing. Okay, so let's go ahead and move on to our actual notes here today. So this is the stuff that we've learned already. Here's our combined gas law. So this top portion right here, where you have P1, V1 equals P2, V2, that's kind of your Boyle's. And right here where we got the V2 and T2, the V1 and T1, that's Charles. And so combined is those two things put together. And like we just mentioned a moment ago, STP, standard temperature and pressure, 1 atmosphere, 273 Kelvin. Now we want to talk about the new stuff here today, which is the ideal gas law. Now, for you honors folks, we are not going to have a guided notes handout here today. These notes should be pretty brief. We're going to spend most of our time working on the worksheet that goes with this ideal gas law stuff. You've been given guided notes the last couple of days, but not today. I didn't want to print for a very small amount of notes, so sorry about that, but I think you guys will live. Okay, so when ideal gas, that is a perfect gas, is one which obeys Boyle's law and Charles' law exactly. Okay, you don't really have to write that down, but ideal gas law assumes that a gas is behaving quote unquote perfectly. We know that's not really true, but most of the time, the ideal gas law calculations are good enough to match with real life. Now, it will include more information than just combined gas law, so it's more than just P, V, and T. And because it takes into account the number of molecules. So you guys might know where this is going, but oh yeah, the mole's coming back. Now, before you panic here, don't worry, it's not going to be anything crazy. They're going to be very basic calculations. Okay, so for those of you guys who are like, no, liberty and excess stoic, please! It's not going to be anything like that. Okay, but this ideal gas law does account for your molecules, that is your moles of something. So let's go ahead and take a look at what this equation is. We have PV equals nRT. PV equals nRT. Or if you're a real dork, you can call it PIV-NERT. 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 Pretty sweet, right, you guys? Ha ha, everyone's laughing. Just kidding, I'm in a room by myself. It's really late at night. Whatever. Anyways, so P, V, and T are all what you think they are. It's N and R that are the new ones. So let's go through each one of these. Pressure is the pressure in atmospheres. Okay, so it should be in atmospheres. Now we are going to learn that there is another unit for pressure. It is called torr. Okay, so if I give you something in torr, which is another unit for pressure, you need to convert it to atmospheres. Mr. P, how do I convert torr into atmospheres? You simply divide it by 760. So for example, if I tell you, hey, you have 638 torr of pressure. How many atmospheres is that? Oh, well, you just got to divide that by 760 to find out how many atmospheres that is. Let me go ahead and plug that into my calculator here. Let's see here. What does it say? 638 divided by 760. 0.84 atmosphere. There we go. So kind of similar to when we convert from Celsius to Kelvin at the beginning of a lot of problems. Just watch out every now and then. I'm going to throw some torr your way to make sure you're not sleeping on your units. Now volume is in liters. Again, sometimes I'll throw it milliliters at you, but you guys know what to do there. That's old news. N stands for the number of moles. The number of moles. And remember, we're just going to worry about the basic moles equation, mass over formula weight. Okay. So that's the only equation you really need to use. Just be careful. A lot of the gases that we use are diatomic. So stuff like O2. Okay. That's 2 oxygens. So its formula weight is 16 plus 16. Okay, for the 2 oxygens, so that's going to be 32. Or N2, for example, that's 2 nitrogens, 14 plus 14, so that formula weight is 28. So just be careful there. We're not going to bust out the molarity equation. We're not going to bust out volume over 22.4. Like, none of those mole equations are coming back. It's just the mass over formula weight. So just got to be careful there. R, you'll be happy to know, is literally the exact same thing every time. It'll be 0.0821. That's just a guy you don't have to memorize it, but you might as well because it'll probably save you some time. But it'll always be the same thing. The units there are liters per atmosphere mole Kelvin. It's not that important to me whether you know those units or not. You will see if you plug in all your units for PV and R and T that they will cancel out and be the same on both sides. But if you use these units for R, but anyways. And lastly, temperature better be in Kelvin. Remember, degrees Celsius plus 273 gets you your Kelvin. Okay? So this is our new equation. I would take the time to write this on the back of your periodic table. And in the atmosphere section, I'd put, hey, torr divided by 760 equals atmospheres. R equals 0.0821. So that way they're ready and available for whenever you might need them. Okay. Now here's where we're going to spend most of our time is on this worksheet here. Substitute. I need you to pass this out, so please pause now. Okay. Well, now that we got this guy here, so there's our little equation up there. Remember, atmospheres not torr, liters not milliliters, moles not grams, 0.0821 is always the same, and Kelvin not Celsius for our different units there, so make sure you convert them when necessary. Let's go ahead and do several practice problems here. Ooh, what's going on there? I don't want that to happen. There we go. So go ahead and you can skip that first one. I wouldn't really worry about that. Let's talk about this next one here. Okay. At what temperature, so we're looking for T, with 2.1 moles, so it's already in moles, that's great, of nitrogen gas at a pressure of 1.25 atmospheres in a 25.0 liter tank. Well, I'm just going to set PV equals nRT. My pressure is 1.25. My volume is 25. My N, which should just be moles, and this is already there, so I don't need to convert, is 2.1. My R will always be the same. It is 0.0821. And that just leaves the T, which is what the problem's asking for, so I don't know what that is, so I'll just leave it as a T. As I go ahead and simplify through, so 1.25 times 25 is equal to 31.25. 2.1 times 0.0821 is 0.17. And that's still multiplied by T here. And what do I have to do to both sides? Well, the opposite of multiplying by 0.17 is dividing by 0.17. So I'm going to do that on both sides here. These cancel out. Boom, boom. And so 31.25 divided by 0.17 should come out to be 183.82 Kelvin is our final temperature. And there goes my box because I'm a model student. Okay, so not too bad so far. Some of them involve more conversions before doing the calculations than others. This is a friendly reminder. I've said this a few times, but your guys' quiz over all the gases, which would be Boyle's, Charles, combined, and ideal. That will be on Friday. Okay. So when I come back tomorrow, that's where we're going to be taking this quiz. We will do a little bit of warm-up and practice. But just so you guys know, tomorrow is that quiz. So friendly reminder there. I don't want to forget the end of the video just in case. Let's go ahead and take a look at number 3. And if you guys miss anything above, the answer key should be in the room, so you can go ahead and check that if you need to. What is the volume of 1.0 moles of a gas at standard temperature and pressure? Okay, well here we got some STP, so that standard temperature is going to be your 273 Kelvin. That pressure is going to be your 1 atmosphere. Volume is what we don't know, so that's what we're looking for. We got moles, and R is the same every time, so we have that as well. So I go ahead and start plugging in here. I've got 1 for my pressure. Volume, I don't know what it is, so I'll leave it as a V. 1.00 for my moles of a gas. 0.0821 as always for my R. And my T this time is 273, because that's the standard temperature. So then volume, so 1 times V just comes out to be volume, should be equal to 1 times 0.0821 times 273, which according to my calculator is 22.41 liters. And don't forget to put that L on there. Don't sleep on your units. Boom, there goes the box. Model student, of course. Okay, it's not too bad so far. The next couple get a little saucier. Okay, so I want to do those with you. We're going to take a look at number 4 here as a class. So I'm going to scroll down, giving people a little bit of time to catch up. So as I'm reading through this, it says what volume is occupied by 5.03 grams. Like, ooh, okay. Well, grams are not part of the Pivnert equation, so I'm going to have to convert those to something. Of O2 at 28 degrees Celsius. Like, oh man, there's another one I'm going to have to convert. Thanks a lot, Mr. P. And a pressure of 0.998 atmospheres. Like, okay. All right. Well, before I get to the Pivnert part of this question, where I have to do calculations, I'm going to go ahead and convert my units where necessary. So N stands for moles, okay? And so we have to convert those grams into moles. We will do that by doing our mass over formula weight equation. So I've got my 5.03, and because this is O2, we're talking about 2 oxygens here, okay? So my formula weight is going to be equal to 2 oxygens, 16 plus 16, that comes out to be 32. So that's where that 32 is coming from. I know a lot of people tend to miss that one. So I've got 5.03 divided by 32. So I have that many moles of oxygen gas to start off with, okay? Now the other conversion, we're a lot more used to at this point. Our temperature, hey, that's Celsius, 28 degrees plus your 273, that's going to be 301 Kelvin, okay? So just make sure you're paying very careful attention to your units. You convert those prior to doing your Pivnert calculations. That way, future you won't accidentally use the wrong value. Okay, so PV equals nRT. Well, for my pressure, I've got 0.998. That's coming directly out of the problem. Up here in green on the very far right. Volume, that's what we're being asked for, so I don't know what that is. Leave it as the letter V. N, I just solved for, is that 0.16 moles right there, okay, at the top. R is always my trusty 0.0821. And my Kelvin, which I also just had to convert from Celsius, is 301. Now, as I sort of simplify things here, I'm going to have 0.998 times volume on the left, 0.16 times 0.0821 times 301. If you want to plug it into your calculator, is 3.95 And I shouldn't have any units on that yet. What am I doing, Mr. P? I'm jumping the gun on my units. I'm afraid of sleeping on my units. I jumped the gun there. Comes out to be 3.95. And then to solve for volume, what do I have to do to both sides? Well, the opposite of multiplying by 0.998 is dividing by 0.998. This cancels. There we go. So whatever 3.95 divided by 0.998 is, that's what my volume will be. That comes out to be 3.96 liters. And there my units officially go now that I'm at the end of the problem. Boom. There it is. Okay. So that's kind of a lot. Drinking through a fire hose here. Let's go ahead. Let's do one more problem. We're going to actually go to the next page and take a look at problem number 6. This is a pretty saucy one, okay? There's going to be a lot of pre-problem, pre-calculation conversions. So, first of all, I see 764 milliliters. But, ooh, all right, Mr. P. Going to be like that, huh? Well, that's 0.764 liters. Thank you very much. So watch out for that. You also have torr, which is an unacceptable unit for the Pivnern equation. We need to get that into ATMs. And the Celsius is thrown your way. Like, Mr. P, how you got to do that to me? How are you going to do that to me? Evil. I just want to make sure you're not sleeping on those units. So, first of all, let's go ahead and convert that pressure. So remember, torr, whatever that is 793. In this case, divided by 760 will tell you your pressure in atmospheres. So our pressure is 1.04 atmospheres in this particular problem. And our temperature, which we're pretty used to, is 92 plus the 273 gets us 365 Kelvin. You should be able to convert from Celsius to Kelvin in your sleep at this point. Pretty basic thing. We've done it a lot at this point in the week. So now I'm ready to plug everything in. So I had 3 conversions there. Milliliters to liters, torr to atmosphere, Celsius to Kelvin. So be careful. If you goof up any one of those and forget to convert them, your final value will be off. So make sure you are not sleeping on those units. So here I've got a pressure of 1.04, converted from my 793 torr to 1.04 atmospheres. My volume is 0.764, not 764, because I want to go from milliliters to liters. N is what I don't know. It's what the problem's asked me for. If you take a look back up here, it says how many moles. Okay, so that's our N. We don't know what that is. So I'll just be leaving it as an N letter as variable. R is good old 0.0821. Love it. And T is going to be our 365, which we just converted from those 92 degrees Celsius. I'm going to go ahead and start simplifying both sides here. 1.04 times 0.764 comes out to be 0.79. N times 0.0821, or 0.0821 times 365 is 29.97. Now let's put the N after that, so 29.97 multiplied by N. And the familiar last step, what is the opposite of dividing by or multiplying by 29.97? It would be dividing by 29.97 on both sides to get that N by itself. 29.97 over here. So 0.79 divided by 29.97 should tell us that we have 0.026 moles is our N. Okay? So that's going to be our final answer there. There goes my proud drawing of a box to lock in that final answer so Mr. Pilcher knows what's to grade, what he's supposed to grade. Alrighty. We guys have the rest of the period to go to town on this worksheet. Again, May 11th, tie-dye, 100% cotton, white t-shirt, 1 roll of paper towels, and your quiz over this will be tomorrow when I come back. We will do practice together in person prior to taking that quiz, okay? So that is a wrap for today. Please email me if you guys have any questions. Answer keys are available up the front of the room. and they're also on Schoology. I'll see you guys next time.